Hi, Assalamualaikum and good morning to panels and presenter. I am Syazwani binti Muhammad Sharif, a PhD student from the UMT Terengganu. Today, I would like to share about the topic of the BRIS potential to absorb carbon. Overall, this topic is to show the BRIS ecosystem services in terms of the carbon storage in the soil. As BRIS is one of the wetland type, it should have the potential to accumulate the carbon. However, this area is facing with the human activities. When we speak about the carbon, it will be related with the global issues that is global warming. So, what is the BRIS soil systems? So, this is the acronym. It stands for the beach, ridges, interspersed with the swale soil systems. Okay, so this area can be found commonly in east coast of Peninsular Malaysia. For example, is Johor, Pahang, Kelantan, and Terengganu. So in Terengganu, it consists about 67582.61 hectare. So how this area exists? For years ago, during the Holocene era, the sea level has risen about 3 to 5 meters above the present high tide position. And after many years, the sea deposits the sediment along the shoreline. So these have formed the sandy beach ridges. So with addition of the flood, it caused the coastal zone to degrade and result the BRIS soil. So this soil contains more than 95% of sands with low CEC and low moisture. Okay, so this is the structure of the BRIS soil system. So as you can see, the swales are located in between the beach ridges. So this area is flooded with water. So while for the ridges, it contains osphodic layer, and these ridges can contain of gravel and sand deposit with the presence of the young alluvium, so which make this layer rich in the soil organic matter. So this organic matter is originated from leaf litter and marine sediment. However, as I mentioned earlier, this soil has a low number of CEC, means it low in fertility and it has a high number of leaching process. So this process can reduce soil moisture and increase the soil temperature. Not to forget the swales area, even it has the water, the soil temperature can increase due to the microactivity, which is clay decomposition. So all these conditions can alter the hydrology system in the soil and change the soil redox reaction. And lastly, affect the SOC. So it means that the drying of this area will increase decomposition. So increase the decomposition means increase of the CO2 emissions. And lastly, increase to the temperature. So this led to the global warming. So this is the service served by this area. So however, this area is facing with the human intervention and change these BRIS soil system conditions. So in this paper, I want to highlight the area which actually has the potential to accumulate the carbon in their soil. Right, so what is soil organic carbon, the SOC? Alright, so soil organic carbon content is critical to determine the quality of ecosystem. So it represents the largest carbon reservoir. So it composed of decaying plant matter, microbial cell, and also the particulate organic substance. So the decomposition influenced by vegetation type, temperature, and moisture content. There are many studies on the topsoil, however, not for the SOC. So this is due to inconsistent input, which is the litterfall. So usually in the wetland, the decomposition process is incomplete. However, with increase of the temperature, which is 10 degrees Celsius, the decomposition can be done faster as microbial respiration doubles. So means that more CO2 emission, and this is what we want to avoid. Hence, it is significantly need to know the importance of the BRIS as one of the wetland. So we should bear in mind we don't want the carbon sink becoming the carbon source. This can happen if the area being converted, the deforestation and also the agriculture. So make this land to be open and exposed to increased temperature. It's been stated that at least 33% of the world wetland have been disappeared, which is a fact from the human activities. So as they able to store about 40% of the carbon, make them as a good indicator of the climate change. So this area should be managed as good as possible to increase the SOC accumulations. And not to forget, the human activity also change the soil salinity. So this salinity make the higher loss of the SOC from the soil through solubilization of SOC. And it also affect the microbes community. So this cause the SOC higher in the non-saline soil. And not to forget, the flood frequency, which this event affect on the SOC distributions, means that the SOC can be located at the topsoil, whereas in an aerobic condition, it will lose the carbon in form of the methane. So this shows that BRIS soil system have potential to store amount of SOC. However, they are exposed with human activities, and not to forget the salinity and flood frequency. There should be more knowledge for better understanding in this resource system in relation of SOC accumulations. So that's all for me, and I would like to give a special thanks to University Malaysia Terengganu UMT and University Technology Mara UITM Negeri Sembilan branch for giving permission to publish this paper. So here's the references, and thank you for lending me your ears.